Hello, Farm Tech. You hear me okay? Well, I'm sure you're wondering what we're doing today. I'll show you. Hi, Michael. Actually doing typewriters today. I think these are all snappable connectors. I don't think... Oh, no, there's 2 screws in the front. So these are Coronas. It's missing the front cover. He's going to get a new one. I know it looks absolutely terrible because it's missing the front cover. Actually, it's not missing it. I have it. It's just broken. And he's got another one he's going to fix it with. But that's how it's supposed to look. But anyway, these have on-the-board batteries, which is an awful idea in every sense of the word. But we replaced those with a new rechargeable NiCad that should last a very long time. So I have those here, and we just solder those in. They're 700 milliamp, 2.4 volt NiCad cells. So that seems to be too big. What about this one? Is it a special screw or something? Alright, what is going on here? Ah, yeah, it's a Torx head. Okay. That makes sense on why it's fighting me, so... That is the right Torx head. That's better. I think there's 2 more back here. Yep, 1. There's 2 more back here. And then we have a cable that plugs our top screen in. That just comes right off. Put that to the side. Then we gotta remove our keyboard here. Which is just some plastic clips. Don't we all love plastic clips? I love plastic clips. And that comes off. It is held by a ribbon cable, as well as a grounding wire. Comes off to the side. And there's our battery, and he has started to corrode on our board. Plastic clips. Heart emoji. Yeah, exactly. So he started to corrode on our board, which is not very cool of him. And we got 2 giant filter caps. So this guy wants a full service, so we will probably be at least replacing his big filter caps. And this axial one looks like it's going to start leaking anytime now. So let me see if I can... That's 100 microfarad. So we got a lot of screws on this. That one didn't feel like it was in anything. You gotta watch. Some of them are plastic and some of them are machine screws. So you gotta remember what's what. All the top ones I'm pretty sure are plastic. That's a machine. Really just gotta look in the hole and see what one it's connected to. Okay, so now we just connect all these. So, take a picture, just in case I decide to forget. And this is 3 connectors, so let's get a picture of that, just in case. Cool. Ah, missed one. There we go. Now this whole board will come out. And we'll go get the other bench warmed up. Okay. Let's see if that's cooperating today. Seems like it is. Here's our new battery. Here's our old one that's starting to leak, so we're going to get rid of him. Boom. So it tells you which side's positive and negative. Thankfully, it looks like he hasn't leaked onto the actual board much yet, if at all. So we're going to just put our 2 wires in here, and then we'll tape this or glue it up here so it's in the service window, I guess. I don't know what to say. So before we do the battery, I'll probably check on these caps. 6.3 out of 1,000. I don't think my one kit goes to 1,000. Does this go to 1,000? This definitely does. This kit. I need to buy another one of these. I've dumped this kit so many times. So that will replace that cap. This axial one's 100. The one that looks like it's getting ready to leak. And then this one over here. Oh, that's an inductor, so that's fine. But these 2 are 33s. This kit has 33s. And what are they at? 25? I might have 33s at 25. Might have. There's one. There's one. No, it's a 6.3. There's one. There's one. How many are supposed to be in here? 5? I'm sure I've used some. Alright, we got enough to do. We have 2 typewriters to do. So we're going to do all those caps on both of them, which means I need another 1,035 if I can find it. Then I need to buy another cap set. 1,000 at 35. There we go. That will replace all our big ones. All these small ones look fine. They're all Rubicons. They're nice. Low voltage, low microfarad caps. They're all ones at 50. I don't know. What do you guys think? Do we replace all the ones at 50? I have caps to do it. It's just, you know, do we want to do all those? Do we think there's a benefit to doing all those? Is the real question. So we'll handle this one first. This one is a Traycon, which is why I definitely want to replace it, because that is not a known brand at all. Never heard of a Traycon. It's a sussy Chinese cap. There we go. Oh, and this is an inductor too. That's millihenry, not milli. Okay, so we don't need to replace that, obviously. But we will replace these two Traycon filter caps. All the rest are Rubicons. You're still good? Okay. Let me see what y'all are saying. Oh, you guys do talk about something. What are you fixing, Michael? Oh, an Xbox One. Xbox Ones, huh? Hate Xbox Ones. Me and my homies hate Xbox Ones. Because I suck at repairing them, that's why I hate them. Not because they did anything wrong, just because I'm bad at it. There we go. I don't think those were even leaking, but this guy wanted a full service. We'll give him a full service. Which includes replacing all his sketchy capacitors, aka the Traycons. Okay. This part of the board looks like it got burned at one time. What is that guy? That's a 220 ohm resistor, 2 watt, 220 ohm. Man, that thing must get hot. Alright, battery time. That's in your guys' way. Okay, battery time, battery time. Wish we had the other ends of these so we could actually use the connectors, but we don't. There are actual wire strings here. You guys are being a bunch of nerds in my chat. Cannot believe it. Listen to you guys fixing stuff. What's wrong with you? Here we go. Okay, that's gonna solder right through there. Let's tin it first and get it kind of how we like it. I keep trying to put my wire cutters in the trash. I don't know why I keep doing that. Am I having a fucking stroke tonight? I keep looking over like, oh, where did I put my wire? Oh, they're in the trash again. What am I doing? Alright, that's a new battery, ready to go. And the big caps have been replaced. So we'll take it back over here. Matthew, what's up, man? I'm listening. I'm here for you, man. What's going on with you? What is going on with you, brother? What is going on with you, brother? You got something to tell me, huh? So we got orange, yellow, red, red. That is that one. We got that one. Element. Then we got orange, yellow, that. So it goes right here. So it goes here. Michael, amen. Hit that motherfucking like button. It's actually. Oh. Probably shouldn't have the owner's contact information easily visible on my desk. Tristan. Good job. Okay, so these caps are both the right way around. Yes, he's the right way around. Yes, I don't see a mark on the board for him. He wasn't bipolar, was he? No, he wasn't. Okay. So we got a battery now installed. I need to get a roll of double-sided tape to put him down on top of something. I think last time I put him on top of this chip here, like that. He can't really sit out here because he'd be in the way. So, or I can fold him up and get him right like that. That's probably the best place for him, like that. But in this configuration, let's make sure he works. I think some of the buttons don't work, but we can work on the keyboard next. We just need to make sure this typewriter still works. So I think it should work without the screen. So let's get all these screws out of here, so we don't touch them off on something. And we'll plug her in. Maybe. Oh, it's a wraparound. Okay, there we go. Ah, it scared me. Oh, okay. Okay. What do you need? You need something on this to tell you already all the way at the end? What tells you you're all the way at the end? Ah, you do, and you're unplugged, aren't you? Yeah, okay. Let's plug him back in so he knows he's made it to the end. So he stops jamming. Where is your connector at, friend? Just a little 2-pin. Where is it? I remember unplugging this. There he is. Right there. We can go underhand like this and then down. There we go. Good job, Tristan. Trying to break stuff already. Okay. There we go. Very good. At first I thought maybe the switch was on the top screen. That's not true. Okay. There it is. Interesting. Stop. Oh. We had a transistor pop off. Yep. Why did that happen? Let's get this back out. There we go. Up and at 'em. Up. And at 'em. So went right around 1,035. I'm really not sure what that's about. What that was about. I think that transistor's toast, but I don't see any obvious reason why it would toast itself. We have a whole nother one though. Oh! This is a 440, it's a little different. We can put these screws right here. This one might be a different board now that I think about it. Let's see. Yeah, kinda. My god, how many connections to the bottom board does this have? Jeez. There we go. Yeah, completely different board. Same transistor though, I think. 6039 and 6039. No, that's a 6035 that smoked on this. I don't understand why it would have smoked on us. Unless the solder mask on this is wrong for the direction of the cap, but I don't think so. Let's see, is it completely dead now? Let's plug it back in. Is there a power switch on it? So just turn on power on. Good luck on your repair, Michael. Good luck. Yellow, orange, yellow, yep. Is there really no on switch on this? Or off? It's not. I guess it's just plug the sumbitch in and let her go. This power should be right here. Wall voltage should be right here. Well, it's actually after a transformer, but still. That goes into that transformer. Out of that transformer comes this. There should definitely be AC on this. This is right at the beginning of the circuit. The only other thing is this, but that comes from the motor. This is the ring that goes into the transformer. Yes. Goes in. Okay, that's getting hot. 34063 API. KQCY. Jesus, that's a complicated part number. But it's getting hot. So why is that getting hot? Does it have to do with our little battery friend? What was our old battery? He should have been within... Yeah, it just says Sanyo 2N110AA. And I have a 2.4 volt, 700 milliamp battery. Should work. I've used it on other ones like this. So why is that getting so hot? Let me go back to the other bench. So I get to fumble with these. Trying to be good. That was the 50 at 22. Might not have one of those. I do right here. and see if I got any more of these boards lying around, which I used to. Be right back. Alright. Oh, not the cam I wanted. Hey, Nick. What's up? Alright, let me look at my photo here. Orange, yellow, white. Okay. I don't get it. Why is that getting so hot? What is overpowering that? It's a typewriter. He's right. Why are you booing me? I'm right. Yeah, that's definitely supposed to be ground side, and it is ground side. That's 1,035. So we have our old cap right here. It's 1,000 micros. So that's probably, is that tied to power lead on that? No, it's not. But we're definitely getting a voltage issue on that chip where it's heating up really quick. That's going through this millihenry. That down here. Right? Yep. And that goes up. Oh, that is on that cap. It's on that cap. On my 1035. Okay, I'm gonna put the old cap back in because it really doesn't like this one, but the old cap definitely says 1,000 on it. I'm really confused. Oh, my possibly came off on my battery, but that's okay. Fix that later. Just get the board working. Starters. Yeah, that's not right. It's starting to heat up again. What the fuck? What happened to this poor guy? He might have not worked to begin with, to be honest. Was there any complaint on that? I don't think there was a complaint of it not working. Let's see. This is the... What is this? This is the 400. Okay, well... Man. Okay. I need... We'll look at this chip. See what the fuck it does. This is gonna be a weird one. I'm probably not gonna be able to find this online. 34063 AP1. Oh no. I can. Oh, it's a switching regulator. 4 battery chargers. Okay. So, it didn't like my battery? Why not? Is that why it's all upset? It's because of my battery? I didn't even do anything. What did I do? I'm about to put all the old caps back in and just see if any of my changes are what made it freak out. Take it from the top. Yeah, she's throwing a tantrum, and she's smoking a chip, which is really nice. Smoking a chip. I'm trying to figure out why. It might just be smoking that chip because of... God damn it. Two 50s in the back. Look up this battery. I'm pretty sure. Yeah, it's 2.4 volts, which is what our battery packs are. So what I'm probably going to do on this board, I don't know. First, let's take this battery off. We'll use this battery on the other one. Verify its voltage first. Figure out why it's blowing up our one. 2.4. Yeah, it's a fully charged cell. Move this out of the way. Okay. This one. Battery looks like it's definitely getting ready to leak, but it hasn't yet, which is good news. Good news. That's power, so. Okay, let's add all the screws. Yes, yes, okay. Let go, let go. Cool. Okay, so we got the battery installed on this one now. Power goes here. This one actually does need all the BS on the top because it's quite a lot of BS. It is an insane amount of stuff that plugs in, and it's hard to do so. I don't know who designed this, but I hate them. Yeah, that's not going to do its job, is it? Poor Josh, you found me. Yes, it does not. It does not. That is why I use it. If this lid would stop falling, we would be in good shape. Okay, this is power switch. This is mode switch. And I gotta pull this ground out of here, come on. Or just hold it at least, I guess. To get it to slip onto that. Yeah, not gonna do it, are ya? Ah, come on. Taking stuff apart's easy. The putting back together is the hard part, right? Oh god. Never have my hand the way I want it when I get it to fucking attach. There we go. This thing is a nightmare to put back together. Wow. Jesus Christ. Go. I think that should be everything good for a test. Everything should be plugged in now. Power, yep, hold that. The battery. Batteries are the way down. Yeah, plus is on the plus side. If this smokes too, I'm gonna rage quit. Does this one have a power switch, unlike the other one? Oh, we gotta turn on. Then we gotta turn this on. Okay. So, did we forget that little fucker switch? Yeah, we did. It's right here. God damn it. God damn it. Okay, we can just unplug this and this. And it will move up quite a bit in this. And we can get him in. Which is over here. Here, buddy. go right here. Like that. Okay. Should be happy now. Let's find out. Lid ribbons. The lid probably... Oh, does it have a lid switch? It does. It does have a lid switch. So I have to hold that down. Okay. What do we do? It seems happy. Lid switch. Gotta get that lid to go on right. If the lid's not on right, there's a switch that is a safety, and if it's not depressed, it will not let the startup mode continue. There we go. Okay, so it's still mad about the lid. Close the lid. I hit that switch if I hold it down. What is it jamming? What tells it it's home? Is there something that hits? Usually there's a piece of plastic or something that hits that tells it it's all the way home. Everything is plugged in as it should be. Yes, yes, yes. Yes, 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 yes. Oh, Jesus. Maybe it doesn't like that. I don't know. This one just blew probably the same chip. I'm starting to think that these batteries aren't going to cooperate. I didn't change anything in this one other than the battery. But it is the same voltage battery, and I put these in other ones before, and it was fine. So I really don't get it. They're Sanyo 2N1100AAs, and I'm replacing them with 700 milliamp 2.4 volt batteries, and they're both 2.4 volt. The capacity is just higher on this one. I don't get it. Why is it blowing these up? It blew up both of them. It blew them both up. Where did I put that board? Over there. It's got two of them on this one. I'm assuming that's the same chip. Sorry, man. Where is my chip wick? And we will steal one of those from this one. Right over here. And still trying to hold on. There we go. That's our one that isn't exploded. Let's put him in here. Solder him in. Okay. Oh, I see what's going on there. Okay, no battery on this one. Any more? Line feed orange that side, yes. Then we got orange, yellow, red, yes. Then we got this one. Then we got orange, yellow, red. Okay, and we got the line feeder right there. Now we gotta put all this shit back on, which is the button to turn it on, the mode switch, The ribbon cable that they put all the way halfway down to make it freaking impossible to get in. And then this guy all the way at the front. This is your screen. Okay, let's see if you blow up that fucking chip again without... Okay, it's mad about the lid, which we can fix. Just hold that button down. Nope, it's still mad about the lid. Did we forget to plug that frickin' thing in again? Yeah, we did. Why are we so bad about that? We did that both. No, it's plugged in. That is plugged in. It's got ribbons. Well, that's just sitting on there. Yeah. Hey, there we go. Okay. Well, we fixed this one. So, I don't know if you guys can explain this to me, but the original batteries are the Sanyo, they're two 1/3 cell AA's, nickel metal. And they're 2.4 volt total. There are much lower milliamp. They're like 100 milliamp versus these are 700 milliamp hour, but they're the same voltage. And this battery is blowing up the DC regulator for the battery. And I don't know why. It's the same voltage as the original battery, and it's just cooking it. It did it on both of them. I've replaced these typewriter batteries with these before. Too high charge current? I mean, I guess it could be. I've replaced batteries in these before with these. I swear it. I swears it. Because you can't buy these 2 cells wrapped up. You can't buy these anymore. So I found these on AliExpress, let me show you, okay? And I had put these in them before and they seemed to work fine. But obviously not! So I think this guy's just gonna have to live with not having a battery, or I'm just gonna have to find a better replacement. So I need 2... I already looked for these and I struggled to find them. Maybe this when I did this was before AI was a thing. This was probably over a year and a half ago, so... There's a guy that sells direct drop-in replacements, but he does not ship to the United States. Motherfucker. I just don't get... I've seen batteries with a good voltage and low ampere too. Yeah, they're both NiCads too. They're both NiCads. They should have the same charge and discharge rate. I'll give it. Okay, someone has 3D printed a ×2 1/3 AA battery holder. Okay, I can use... Okay. So I bought these a long time ago. Not too long ago. Where is it? Here they are. So instead of using 2 half cells, can I not just use 2 full cells? Is that not the same? 2 full cell AA's? It's just capacity. It's the change of the half versus blah blah blah, right? Yeah, they're 1.2, so it'll be 2.4. Yes, I can do this. Okay, we're doing this. And I'm gonna put them in a... Yes, okay. Here we go. I have these two, these little battery holders. Alright. And I would need to rewire this to be a 2-cell holder. Or I just put a piece of metal in the last one. I just gotta hook these two together. And then I can solder this in, and we can put this in instead. I don't see why this won't work until we blow up this one. Fuck it, let's try it. Alright. What he said. Yeah, we'll solder bar it or something. I'll just get a wire and solder in there so that is that third place is taken up. We'll just get some wire or something. Yeah, we'll do a little piece of wire. Got some wire. We'll just do some wire in that. And then we'll solder this holder in, and it will fit. It can fit just on the... I wish we could fit it under here, but we can't. It's going to be in the way of the thing, so it'll have to go, like, somewhere where it's not easily accessible, which kind of sucks, because I would like it to be easily accessible. Okay, anyways, let's get this out of here. Okay. Okay. Well, we learned something today, I guess. Thankfully, we saved this board before we fried it. The other board, I don't know yet. We'll have to figure it out. See if we fried it or not. Okay, that's soldered in. Side soldered in. That fall out. I tried to. I saw it. Okay. Now we just need to do a piece of wire between the last 2 terminals. So it needs to be about yay long. Yeah, so people that are new here are probably wondering why I'm even working on this. Well, I live here in Dayton, Ohio, and we have a typewriter shop, probably one of the last ones around. And he enlists me to do his electric repairs because he doesn't do electric stuff. So I do all of his electric repairs. He does all of the mechanical typewriter repairs, and you would be surprised how much clientele he gets for something like a typewriter. It's quite. I didn't expect it when I started doing this, at all. I did not expect to have this much work doing typewriters, but I do. Let me tell you, I do. Can I solder this? Is the question. Yes, I can. Alright, good. Can I solder to the spring? Yes, I can. That side's done. Bring this in here. That's done. So now if we take two nickel metals and put them in, like so, we should see voltage here at the battery terminals. Let's see if we do. Oh yeah, that's where Hamfest is. Yeah, I've been to Hamfest. It's pretty cool. Right here in the neighborhood. I don't see any voltage there. So, why snot? I see 1.2 volts across that. Oh, I need to go like this to this to see both of them, huh? Oh, wait. Am I an idiot? Yes. Yes, I am. This isn't going to work like that. I need to just defeat the fact that this one... No, that should work. Because it's... Yeah. Because these two are together. And this goes to here. Right? And then this goes to here. It's got an on-off switch. We have an on position. Let's see, where does this one go? This one goes here, up here. Yeah. So that goes here. That's our first battery. Then our second battery here. And that goes all the way over here, I mentioned. Yeah. So, this should be... Yeah, this should work. Why wouldn't this work? So from here to here, I should have voltage. Yeah, there it is, 2.5. Yep, that's good. And then over here I have 2.5. Why not? Unless the switch thing back here is backwards. Should be on. The 2.4 here. The 2.4 here. The 2.4 here. Yes. Okay. So now I should have it through that wire. No. Or maybe it's because the board is dragging it down? No, that can't make sense. Make it make sense. Make it make sense. How can I get into this thing? No, I am an idiot, big team. What's going on? I don't want to chat. I'm gonna let Michael and Yankee talking it out, and I'm gonna figure out why I'm being a big idiot head here. Okay, let's see. Do I have continuity? Do I have continuity between this and this lead? I do. Do I have continuity from this and here? I do, but it's... There we go. So now, if I switch to voltage... Okay, I see 2.5 here. Oh, am I just not getting in there good enough? Why am I not seeing voltage at the lead? It doesn't make any sense. Unless... So that beeps there. Doesn't beep anywhere else, because this is the positive end of our battery setup. And then this beeps here, all the way over here. So that is a complete circuit. We get voltage here, 2.5, but if I come down here, I don't. So the only... That doesn't make any freaking sense. That make no sense. Especially when I get a positive beep out of it. Now, so my ground side's good. All the way up to that battery there. Yeah, because there's 2.5 volt. And if I take it to beep mode and go from here to here, I have continuity. I have continuity. But if I do voltage from this end to this end, I don't get anything. But if I do from ground to the starting terminal, I see 2.5. And I do get continuity if I do that to the starting terminal. So this should be good. I just don't understand why my voltage check isn't working when it works here. But whatever. Whatever, I guess. Ah, is that battery just not... Ah, maybe that's why. Is that battery not making a good connection in there? go. There we go. Okay, that battery wasn't making a good connection there. Now it is. Okay, now we got voltage on the board, as we should. These are soldered in good. Seem to be soldered in good. So now we can put our cover on this battery holder and tack it down to the board. But before we tack it down to the board, we want to make sure we got it somewhere it can live. Foil paper on the contacts. Okay, so I have, this one had a lid too. How fancy is this? Look at this. A little lid to it. Wow. Like that. And I have this fancy alien tape that we can use, but I want to make sure it's somewhere where it can not interfere with anything, which might be hard to find, to be honest with you, because this is a big battery case. It's a pretty big battery case. Now, we could do some longer leads and put it all the way over here in this little crevice if we need to. Let me get you guys a better view. Like all the way over here. I'm just going to put the lid on and see if it will sit like that. If it'll sit like that, I'll just plug it in like that. Is our power off? Yes. Okay, good. Always check that first. Okay, so let's get everything connected other than the lid off the rip here. So we have this guy right here. We got all of these colored ones, which are marked. So that's blue. And that's yellow. Is yellow hiding under the board? Yes, it is. Get it up. There we go. And then orange. And then this guy. And then this guy. And this is orange, yellow, red. Yes. Very good. Okay, all that's connected. Then our mains power into the board is connected. And now we can put this on. And this is power switch. And then the mode switch behind him. And if this blows up my regulator circuit, I have some fundamental misunderstanding about how batteries work. Okay, you're gonna be a pain in my ass, Mr. Ribbon Cable. Yes, you decided you are. What an awful way to connect two things together. A press-fit ribbon cable. May I vent for a minute? Who decided the press-fit ribbon cable was a good idea on a keyboard that is getting constant vibrations and is supposed to be mobile? Mobile! A press-fit ribbon cable on a portable device. Who designed that? I want to speak to him. I just want to have a word with him. Because that is horrid. Okay. Okay, this is still sitting really high. Why is that? That's why. So now that will go up. Now that's sitting fairly good. Okay, is it going? He was pressed. You tell him, Big T. Yes. Okay, so everything's plugged in, minus our keyboard grounds, but that's fine, whatever, who cares. Let's make sure they're not touching off on something, though. It's the last thing I need to do here. Let's have my ground cables touch off on something stupid. This needs to go like that. Okay. Okay, we have no life. So what has happened? So that's all good. We have our power plugged in. Oh, we've swapped the mode and power. That's okay, they're both the same switch. We'll just flip the other one. Yes, okay. That looks pretty normal. It's still angry about the lid. That's because our lid is not on. So now... Okay, it's still mad about the lid. I might have to do the lid with my finger. Just to make it happy. No, it's still mad about the lid. Did we forget to plug that in? The lid? No, the lid's plugged in. Okay. Oh, our ribbon is pushed up, which usually... There we go. Now it should be happy. There we go. Beautiful. Okay, we're gonna leave this on and see if it explodes. No explosion yet. Very good, very good. Okay, so let's turn that off. Let's unplug it. And let's see, is that gonna be able to sit there like that? If we put it all the way back together, our battery. Is it gonna be able to sit there? No way. No way. I think we are gonna have to put it down here in the bottom corner. Or, honestly, that's probably the best place for it because I don't really see anywhere else it can sit. Yeah, because that is gonna be, that's too, there's not enough room anywhere else for that giant battery holder. Except down here in this corner. That still might not be enough. Okay, so everything has to come back out anyways, because we have to tag it down. But now we know it works. Do we have power off? Yes. Always double check. Okay, everything is now disconnected from the top, so we can move the top. So what I'll do is I'll run a longer cable here. We'll cut this and lengthen this a tiny bit, and then we'll put it right here down in this corner. I think that will be best. And then I'll run the wires into that, and that will be good. We'll do some heat shrink on those so they don't touch off on anything, and it will live down in that corner. So, okay, let's make those extensions real fast on the battery connector, and then this one will be done other than the keyboard issues, which I think he noted some keyboard issues as well. I had the piece here, so on the 440, he said, sometimes keys and letters and numbers get mashed up. The memory button is touchy. It takes an effort to make sure it's on memory. Check battery, blah, blah, blah. Okay, so I think a lot of these issues will be fixed by cleaning the wheel. I don't think this has any keyboard issues. And cleaning the memory button, which is just some deoxit in the socket. So, okay. The things you find in Dayton. That's right. This was an innovation hub. More inventions came out of here than anywhere else in the world in the 1880s. First city with an electric trolley, all sorts of crazy shit. Now it's just another city in the Rust Belt, but it once was a really cool place. So we have a lot of old electronic stuff here. NCR was headquartered here for a very, very, very long time. So the first giant IBM mainframe computers were made, well, not made here, but used here by NCR. NCR actually made their own computers, and I have 2 of them. They're very rare. They're not very rare here in Dayton because where else would they be? But for the rest of the world, they're very rare computers. I haven't done a restoration on that yet, and one of these days we will. But if I keep getting jobs like this, it will never happen, will it? Oh my god, I have so much. I never have enough time to do anything. That's okay. Okay, alright. Now, I'm gonna break the board real fast. We'll make this cable a hell of a lot longer. Okay, let's get 2 of them about the same length here. Okay. There we go. Okay, and now we're gonna solder these into the slots here. There we go. There we go. Okay, and now we're going to solder that to that, but first we want to heat shrink it because we do not want that randomly touching off anywhere on our board. So do I have to shrink that small? I think this is my smallest one. I need to get more. Actually, I have a whole nother set out in the barn. I should bring it in here. Okay, so we'll put that on there. And on here. And then we got to do this. And that one is already done. And now we just touch these together and make them keys. Now keys. Where's my little plastic holder? I haven't seen that in a minute, so I'm probably not gonna find it, am I? Let's get solder on both of these, and then we'll just have to manhandle it, I guess. I like putting one under something. There we go. Beautiful. And now we do the same thing on the ground wire. We'll get that to be good. There we go. Okay, and now we just turn on our heat. Shrink that. Oh, not like that. Shrink it actually over the thing, please. There we go. Shrink, shrink, shrink. Okay. Good. Good. Those aren't going anywhere. Okay, now we can take this back to the... Do you use the oscilloscope? Yeah, from time to time I do. You will see me, once I get back out in the barn this summer doing arcade machines, once I get through all these customer orders and everything else, and get some actual time to do my own stuff, you will see me doing a lot of oscilloscope work, diagnosing chips out there. But when we're working on stuff here in the barn, or here in the basement for customers, it's really just component replacements and stuff like that. So usually not too much oscilloscope work down here in the basement. But okay, so that's off, so we're good there. Now we need to put this board in for reals. So, man, it wants to move on me, don't it? Okay. So I think this one's blue because its one's not marked. Yes. And then yellow, and then orange, and then this one, and then this is the last one, and it's orange, yellow, red. Yes. And then this one goes right here. There we go. Now, how am I going to get this to stay? It is kind of being held by other forces. If we do it this way. Ooh, it does like to sit like that. That might be nice, like that. Tuck these wires in here. And I don't think it's going to move much even without much more intervention. Okay, so that needs to sit right here. There we go. And then this one over here. Beautiful. And then we had two machine screws, not plastic ones. They were there. And I think right here. Maybe not right there. That looks like it has a place. It definitely was there. Looks like it's been depressed. There we go. Now it's not depressed. We made it undepressed. There we go. That's in there now. Yes. Okay, so that's hooked up, that's hooked up, that's all good. This is going to be in the way of our ribbon connection, so we can route that up here and around the speaker. I'm going to first see if this just is happy just hanging out, or if it's going to flop around in the breeze. I think it's going to be so tight in here, it's going to be fine. But okay, so first thing we'll do is the annoying one, which is the ground wires. So we'll do those first. Maybe. Man, that's why I kept not putting these on, because it is such a pain in the ass. And they put these nice heat shields on them, probably to keep them from touching off on stuff. There's one. There's the other one. Okay, those are both plugged in. Now we can bring the top down. Yeah, we also have a lot of shipping. There's mostly just shipping BS going on at the Dayton International. It's an international airport, but I don't think there's any commercial people flights. It's all just shipping. Okay, that's in, that's in. That should all be good. Will it sit? Looks like it will. Looks like it's happy. Now we can put this in back here. There we go. Okay. You waiting on me? Okay. Give me a second. Almost done. Okay. So now, everything should be plugged in the way it wants to be. Got that switch on there right now. Okay. Seems happy. Okay, I'll be right back. Give me a second. Love you. Okay. So now we just got to put this thing back together. And that's 4 screws. And I think it's 2 down here and 2 on the back. So let's get these 2 in. There's 1. There's 2. Three. 4. Okay. Now we can get some paper. We'll turn it on. We can feed it. It's supposed to go behind that, I think. Oh, that holds up. Okay, there we go. Yeah, like that. Seems like his cartridge is running out. Oh, it's not moving the cartridge. Is it empty? Try again here. Doesn't seem to be moving the cartridge forward. Maybe this is just, maybe this ribbon's just empty? Okay, so we can trick it into thinking there's ribbon. Just put that down and push this down. Oh no, it's not that simple. I thought I could defeat it easily. Maybe not. Okay, so it's working, but it's not advancing the reel. Yeah, because the first few letters are good, and then the rest are bad. So why aren't you advancing the cartridge? I can advance the cartridge by hand. Is that something we broke when we blew up that voltage regulator, I wonder, or what happened? Something not plugged in. It should be. Let's turn it off. These all seem to be down all the way. Ah, no, that's not in the way, is it? No, it's not. I don't remember this being a complaint originally, that it didn't spin the... that it wasn't moving the... Let's find out where that is. Oh. Yeah, that's not spinning. Why aren't you spinning? Are you on a motor? Really doesn't even look like it's on a motor. What does this thing over here do? Oh, that just detects if we're at the edge, I guess? And this thing does the same thing? Let's look at the one that's taken apart. It should be the same. I don't see where a motor would even interact with that, to be honest with you. Yeah, come on. Oh, wait, I see it. It's back here. It's supposed to be hitting. This is supposed to be moving back and forth. And it's not. And that is the 2 yellow wires. So let me see if those aren't plugged in for some reason. Let's turn it off. Are the 2 yellow wires not making a good connection? No, they definitely are. Oh man, this makes me think we fried more than we thought. That really sucks if we did. That means I gotta figure out what controls. Like that could be a something really complicated. Yeah, that should be it. Those 2 yellows. And that is yellow, yeah. Okay. Oh yeah, it's gonna want the ribbon in it. Yeah, I don't get any movement in that solenoid at all. Damn. That really sucks. Let me see if I get voltage to it. Well, I don't know if I'll be able to. Oh, that lifts the thing up. That isn't even the one that. What? I don't understand. What makes this arm go? Oh, it's the same one. It's the same one. I think. Yeah, it's that yellow one. So if it lifts it up, then it's doing its job, right? Okay, fine. We're taking it back apart, I guess. Man, that really sucks. Yeah, I don't think the teeth are broken. I think something is just not triggering that motor for some reason, and it could be because we fried something when we put the other battery in earlier. That just slammed open. That's amazing. don't lose the screws. Ah, that's so close. That's what it was. Okay. So now this whole thing should come off. And we'll see what... Hopefully something's just unplugged, but if not, we'll see what's going on, I guess. So we can lay that up there. Will you go any farther than that? No, you won't. If I unplug this, you go farther now? Yeah, you will. Okay, good. Okay, let's see here. So we got orange, yellow, red, red, which is definitely that plug. We got this plug. And then we got orange, so yellow, orange, yep. So that is definitely go there, that is definitely go there, and that is definitely go there. Everything seems to be plugged in just fine. Where's my phone? Black, brown, red, red, yellow, orange. Yep, that's right. And this should say white, white, and it does. I mean, everything looks fine, I think. I don't know if we're going to find anything. Pull that out. Yeah, it's not doing it. That should be hitting, I assume, every time. a letter is pressed, and it's not. And the only thing I can think is that we fried something when we overvolted it, and it will be so hard to figure out how. Well, actually, no, it won't be too hard if we can just see where this goes. 2. Oop. Up you go. Yeah, well, just kind of sit in here and speak nonsense. Sounds about right. So we got yellow, which yellow goes to these, which is this solenoid. And yellow goes back to a diode, and then from the diode, it goes to this transistor, which is a N6039. And that signal comes from the resistor, and then there's this Q10 that's also in the line of that. Man, there's a lot of shit. Let me see. So is this the ones going to that thing? Yes, it is. Yes, it is. Yeah, that's what I thought. And that goes to the center leg of this through the diode. Yep. Okay, I got a short across that diode. Emitter and base are shorted on this. But that's just going to a solenoid, so I probably will see a short across the diode, because it's just on each leg of that solenoid. So I'm just seeing 9... Am I seeing 9 ohm? Yeah, like 9 ohm, so that's totally the solenoid. It's just across the solenoid. Solenoid's pretty free moving. It doesn't seem like it's stuck. It's not lit. It's supposed to lift. So mad at myself that I fucked both of these up before we figured out what was going on. This project should be done by now, and it's not, just because I'm an idiot. Yeah, that's spinning that down there. Oh, that leg doesn't want to stay on that anymore. What's going on here? What does the other one look like? Oh! No, it's away too. Okay. typewriter. Boy. Boy, oh boy. So we can... I mean... One, we can go through our parts and see if we can just swap the board. We can probably just swap the board, but... Yeah. Let me go see if I have a 440 exactly. I think I have a 4400, which probably isn't just straight up compatible. This is out of a... What is this out of? This is out of a similar one too. This one's got some bad corrosion on it from the battery. This one had a little corrosion on it from the battery, but it wasn't terrible. I'm sus of the transistor, because that was right next to the battery on the other board. Swap the board. I'm gonna see. I'm gonna see if I have this board. I might have it. I come back empty. I do not have another one of those. Could be our friend here, the P3055E. It's just folded over on himself. It could be so many things on this board. What's going on here? Oh, it's lifting that because that's broken. Unplug that. Leave that down there. Doesn't need to come up with me. That whole power cord lives under. There you go. And that doesn't mean I can't go to the typewriter shop and get another one. Let's test some stuff here. Where is my multimeter? Where did I put it? Over here on the floor. Good place for it. Well, that's good now, I think. But that's not going to fix our motor not engaging that. Oh, our one screw fell down under there, didn't it? Yeah. If we just get a little jumper, we can actually turn this on without the top on. It's probably going to be really angry about, well, it might not even care about not having the keyboard. We can actually press that down to where it gets stuck, and then we have that on. So then we can check voltages. All we got to do is short that, and I can just do that with alligator or something. This is actually fun. We can see if we can get this thing to turn on without having the lid on. Yeah, we just short those two together. Let that dangle. All that's plugged in, that's plugged in, that's plugged in, that's plugged in. Yeah, there you go. Of course, we can't type a letter. Well, we probably can by just shorting two of these. No, okay. At least see if anything feels hot. Yeah, I don't think this is going to teach us anything, is it? I don't think that's going to teach us anything. It's cool that we can do it though. But yeah. That's definitely supposed to be yellow. That's definitely supposed to be blue. We could take the keyboard out of this. I think it's just plastic clips holding it in there. That way we can use the keyboard and not have to put this. Yeah, we can. Just one clip here, one clip here, and the whole keyboard comes out. There it is. And now, let's take these grounding strips off so we don't have to mess with those. We can plug this in. And we can fuck with it without all that shit in the way. Short those together. Like that. Move that over there. Now we can see if we see any sort of voltage. It's going to be an AC voltage on our line here. No, we don't. I see 1.5 volts on our thing here. I see 17 volts between that and that. What is this doing? $18 volts there. 18 volts there on that transistor. We can see if that diode's blown. I don't know why that diode would blow because of our issue we had, unless it was stuck on and blew it up, or because everything else is working fine. I can type. Why would everything else? Oh, why would everything else work fine except that one thing? Wait. No, that's good. We got 12 ohms across that fuse. I thought maybe we just found it with a fuse, but... Yeah, I can't diode test this because it's... Yeah. It's between the... Well, yeah, I can. I can unplug this. If I unplug this... 0.4 that way, 1.2 that way. I think that's okay. What we can do is we can check that against another one, because this one's more or less the same setup. It's a different board, but yeah, it goes to that transistor there. Let's see if that reads the same, more or less. It does not. Is that the same? Is it the same thing? At N603? Yeah, it is the same. It does not read the same, though. I get half a volt that way. Half a volt that way. Okay, and if I go to this one, I get half a volt that way. Half volt. Okay, so it is good. Never mind. It's the same. I'm tripping. And then the diode, half a volt that way. Open that way. Ah, interesting. This diode, half a volt that way. A volt that way. That should not be like that. No thanks. I don't think that diode should have a volt and a half in the wrong direction. I need to figure out or learn damaged diode. Yank thinks it's a damaged diode. So let's look at the... Get out of here, bro. Let's look at that diode track. Because make sure it's actually involved with yellow, which I think it is. Yes, it is. It's a 4933. So let's pull up one leg of that and see if it still tests bad in one direction. If it does still test bad in one direction, then we did find our issue. So let's go to the other bench. Cinema. Cinema extraordinaire, that's who I am. Okay, so now, let's check that diode. Now, we got the diode pulled up. No, it's 0.4 that way. An open line that way. So the diode's fine. The diode is fine. At least by all accounts, it seems fine to me. Now I'm going to solder it back in and see if that volt in the other direction comes back. Yes, it does. That volt in the other direction comes back. So what about you? What about this guy? So we take him out. I assume that old volt in the other direction's gone. Yes, it is. Okay, so what if we take one out of another board, like this one, put him in there. Same one, right? Yep, same one. Okay, now is that difference changed? Nope, it's still about the same, with not a lot more, actually. Fluctuating a lot, where it didn't fluctuate at all before. The only other thing we could try to replace is that P3055, which is this guy. He deals with some pretty high voltages, so, and he's the next guy in line, I think. So that comes down, it goes through that diode. Yeah, and it's connected to the line right under it, and that line goes to that transistor, and that transistor is connected to a jumper that takes it over here to ground. That's a ground line. And the other leg goes all the way up here to this resistor, and that resistor goes to a bus, and that bus goes down to this chip here. And that's just power, I think. So what is actually switching the... because that is a ground plane for that leg. This middle leg is the one that actually triggers it. And the right leg goes to this bus for this chip down here, this 7406N. Right? Yeah. And that 7406N goes to a bunch of shit. Okay, so we swapped the transistor. That is the only thing I can think that we could easily check. It seemed to test fine with the middle. Yeah, 0.5 to the outside. 0.5 this way. Yep, which seems fine. And these two are open, right? Oh no, the outside legs are not open. They're 0.7. I don't think that should be the case. Yeah, they should not. Okay, we might have found our issue. Yeah, the outside leg should not be 0.7. Pretty sure they should be not connected at all. Yeah, they're dead short on the outside legs. There's no voltage drop across the outside legs. Okay, let's see if we fixed it then. Back to the Batmobile. I need to be more. I need to learn more about transistors. You would think I would know more about like about PNP and NPNs and all that from school, but I really don't. And testing them, I just kind of know the basics of what should be shorted and what shouldn't be shorted. But I need to take time to learn more about that. But doing this is teaching us more about it anyway. So what about that? Does that count for something? Okay, come back, come out of there. There you go. Okay, so now you sit flat against that. So we can't do that under that. Let's take that out. Wrap it around town. Come on. There you go. There you go. Okay. There you go. Lift up. Down. So the only other thing I can think of is that we're missing a voltage because we blew up that one thing and it blew out something else, and that voltage is only required for that one solenoid. Maybe it's like a super high voltage solenoid or something. It's literally the only other thing I can think of. Okay, so that goes there, that goes there, and that goes here, that, and back out, there we go. And this goes here, and this goes here, and our power's off, yes. Okay, and now we can get our alligator clip, and we can short the leads here together, and we can get our keyboard, and we can plug it in. We can turn it on. Is everything how it should be? Yes, yes, yes. No change. Yeah, I don't see any change. So the only other thing I can think of is it's an issue with that chip, the 7406N. So what does the 7406N do? That's a 7406N. Hex inverter buffer, feeding open collector, high voltage outputs. It is primarily used to convert TTL voltage to MOS levels to drive high current, high voltage loads like relays and inductor lamps. Yes. So that should be driving a bunch of different stuff, including our element up here. So, what all would take high voltage? It should be all of these solenoids, I imagine, would take the same voltage. Like, okay, orange is our hammer. So let's see where orange gets its voltage from and why orange is firing fine. So orange is firing fine. So because orange is firing fine, let's look at where that comes from. So that comes from a big-ass rail all the way over here. Or is this ground for him? All the way to this cap, this 3300 cap. Really? Is that really what that does? Orange? And its negative side comes from this Q10. So that Q10 is switching for him. Okay. And that high voltage line for the other one, though, is going to a bunch of shit. So what else is he doing? Or is he only doing... So that's that one. It's also going to these 3904s. I don't know what that's doing. Oh yeah, that's also... Okay, so the 3904s are also going to this guy. So... So that confirms that our voltage is there if they're both using the same... Yeah, because this is orange, and that goes to this, and this goes to these transistors, which is tied to the same line, same high voltage line, that is telling it to trigger that. That doesn't make any sense, because these are literally on the same path. There's just a resistor here, and a resistor here. Or is it, what is this, a diode or something? It's a resistor. And that resistor is going to these, which is triggering this, which is triggering our type element. And then at the same time, it really seems like both of these use the same voltage. They definitely do, because it is pin 14 out of the 7406 that is tied to both the input of this transistor, that triggers the orange, the type element, which is working, and this transistor, which triggers... Oh, wait. Yeah, this transistor, which also is triggered on the same voltage. So they should all be going on. These should both go off at the same time. And the fact that this one's not going off makes no sense. It should be going off. Because this transistor, we've replaced that. That is the only part that's different in this one setup and that one setup. Well, this one also uses a... No, it uses the same. Yeah. They're both going through that cap to ground. Okay, I'm going to take some voltage readings with it all hooked up. Let's hook it back up. I like this. I feel mentally stimulated. Okay. Yes. 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 Let's get yellow out from under. Come on, yellow. There we go. All three of those are plugged in. Mains is plugged in. We got to get our... I was stimulated once. I'm glad you guys are here for it, because I don't feel like most people would be here for this. Because this is not very interesting content. That is spinning that wheel down there. Now, why that isn't a part against that, I don't understand. Yeah, there it goes. So now, if I measure voltage coming out of... I'm going to see 14 volts on that, which is going into this leg on here. Yep. Well, here. Let me verify something. So I think it's this leg on here that's tied to these. Both these. No? Am I wrong? There it is. That leg. That leg's tied to that. That's also tied to that. Yep. Okay, why is the emitter and the base also both shorted on this one? That doesn't make any sense. That doesn't make any sense. Is that off? Yes. Unless I cooked another one somehow. That doesn't make any sense. Because if I'm right here, how am I? Oh, I guess it is, because it goes through that and comes up here to this leg, which is routed. It's like 100 ohm. Yeah, okay. This is a head scratcher. Yeah, that is all connected to that pin over there, right? Wait. Yep, that pin, which is going into this pin of this 7604. The only thing I'm coming up with now is that the solenoid is bad. I don't think we could have fried the solenoid, though. What do I see resistance-wise across the solenoid? 9 ohms? It sounds right. Sounds like what it should see, something like that. Maybe we just replace that diode anyway. That's literally the only thing that's different in the circuit from the carriage solenoid to this solenoid is that diode. But the diode checks out fine. Yeah, it checks out fine. So that makes it real confusing. How is this? I don't get it, man. How is this supposed to work with the emitter and base both shorted to that? The base and the emitter are both shorted. This fuse is good, right? Yeah, okay, the fuse is good. We see the high voltage on that. So let me turn it back on. It slams the hammer at least once when it turns on, right? Do we get one hammer slam? So I can see the voltage spike or something? Do we have everything plugged in? We don't have this plugged in. Yeah. No, we just get a spin. But that spin should also be on the high voltage line, I imagine. Wait a minute. Do we need to have the correction wheel on here? Does a correction wheel have to be on here to get that to do its thing? I don't think so, because that doesn't really do anything. It would test that this moves up and this will move up and down. That will test that. Let me see if I have one of those. Did this one have one? I don't think it did. No, they both don't have corrections. We don't even need the correction wheel, because if we just hit the button for correction, it should move the whole carriage up and erase the line. So if we do that and we turn it on, yeah, it's not. Yeah, it's not bringing it up. Ah, okay. But why not? The only thing I can think of is that diode. But it tests fine. There's literally nothing else. We swapped the transistor. There's nothing else in that circuit that really is different from the type element. If it was something else, the type element shouldn't fire either. At least I don't think so. Oh, what's still plugged in? You keep trying to come with us, don't you, buddy? I don't understand how there could be a world where the one fires and the other doesn't. Because they're both tied to the same line on the 74... The same line on the 7406, and that 7406 just goes through some resistors to get to them. This one does get triggered by a different... R32, which is just to this main line on that. Bleached out. Oh, it's already past midnight and I'm still fucking with this. God damn it, Tristan. What are you doing? What the hell are you doing? Let's see, what is that? What is pin 14? It might just be ground. What is pin 7406? That's VCC. That's power. Yeah, so that's just its power pin, which is kind of what I expected. And that power pin comes down here and goes into the base of our transistor. The other side of our transistor goes to the ground, So we have voltage and ground. And the center pin goes through a jumper to a diode. And that's it. So what is triggering this? What is making this turn on and off? If one side of this transistor is just tied to VCC and the other side is just tied to ground, and the center of it is going through a diode, and I don't get what triggers this. A change in the VCC voltage? I don't. What is possibly going to trigger this to turn on? That's just going through a resistor, right? Yeah, it is. And it's not at all tied in with these transistors at all, is it? No? Think more caps kits ordered. Nice. Hot tweezers. Michael, the hot tweezers. I've been wanting a pair of those, man. Those are nice. You are going to be busy, brother. You are going to be busy. Okay, last thing I'm gonna try tonight, I'm gonna replace the cap, or replace the diode. It's the only thing I can think of. Oh, you know what would be a good test if this doesn't work? Is to swap yellow and red on this and see if it triggers it. If it triggers it, we know the solenoid's fine. If it doesn't, we know the solenoid's bad. We should have done that forever ago. And then we would have saved ourselves this troubleshooting. Because if it triggers it, then we know it's something to do with the circuit and not with the diode, right? Or whatever. Okay, all that's in. Voltage needs to go in. We need our alligator clip for the power switch. And we need our keyboard to hit a button. Shut up, multimeter. Why are you always going to be so loud? Yeah. Stop. I didn't plug this in. I know. Shut up. Okay, so it's still not moving it at all. So if I turn it off, and I'm going to swap yellow and orange here. Well, actually, I'll just leave yellow unplugged, and I'll put yellow on orange, and we'll see if it triggers now. It's not happy. Oh, it's not happy just because this. Let's see if it triggers. It does! Okay, so we know it's not... It has to do with the triggering of it. I don't understand. What triggers that fucking thing to go off? Unless the one I stole this transistor from is 6039. Was it a 60? Yeah, same transistor. Same bloody transistor. I'm triggered. Yeah, I am triggered. I'm getting triggered. Unless there's some weird thing that wire's doing in here that isn't just straight to that solenoid, but I don't think it is. I think it's straight to that solenoid. So, I might have to ask my best friend ChatGPT. We need to be done for the night here very soon, but I'm having fun fucking with this, I guess. Is there supposed to be some sort of voltage drop on VCC and that's what triggers it? Okay. So, on this 6039 transistor, so 6039, say 6039 transistor. Monolithic NPN silicon Darlington transistor. One side is VCC and the other is... Is the other side ground? The other side... Yes. Yeah. The load, the electrical current passes through your device of recover the switch. Connect the other side of your load directly to the 7406 output. Low side, ground, connect Ground the trigger states. Okay, well, it thinks I just have it wired wrong, which that's obviously not the case. It's literally on a fucking circuit board. Are these fuses? What are these? No, those are caps. Those caps aren't involved at all anyways. Oh, our shit turned off. So, the way that this circuit... I still don't understand how this circuit triggers, but the base is tied to VCC of our 7416, which is our high voltage thingy-mabobber. Our 7406. It's just tied to VCC of 7406 through a resistor. So it's got a resistor, a little bit of voltage drop. So that the base has a constant voltage. The base has a constant voltage. Okay? The emitter is tied to ground. Okay? The emitter is tied through a jumper to common ground across the entire board. Okay? And then the center pin is tied through a jumper to our diode, and the diode is across our two pins to our solenoid. So I don't understand how this transistor triggers in this scenario, because it's just VCC on one side, ground on the other side, and the thing in the middle. I don't see, unless there's some sort of voltage drop that happens from VCC that will trigger it, and it's not doing it. That's the only way I could see that this would work. Is if the voltage dropped. Now there is some transistors up the line here on VCC, and they are tied to a bunch of shit. Like, they go all over the damn place. And those I haven't gone into yet. Those go up to the CPU, and they go over to... where else do they go? They go over here to this side of the board, and they run... Oh, they go to power. So these little 2N3904s do some shit as well. Maybe those are somehow messing with the... I replaced that one diode that's in line with this shit. All the other everything else is also in line with the hammer. And if those were kaput, the hammer wouldn't trigger either. I just don't understand what if I have VCC on my base of this transistor, and my emitter has... Well, not my emitter. Yeah, my emitter, right? They do have this symbol right here that says 0.75 amp, 125 volt. And I don't know what that's for. I don't know if it's for the transistor or if it's for... Now, and there is a mark here that says fuse 2, but fuse 2 seems fine. It's got 11 ohms across it. It's got 4 bands. Where's fuse 1? If we found fuse 2, there's got to be fuse 1, right? I would imagine. Probably be over here by the power in. I just don't understand how this transistor is meant to trigger the solenoid. If it's literally just, yeah. I'm going to have to talk to my best friend AI about that and figure out what the fuck is going on there. Orange, yellow, red, red. Da-da-da-da. Da-da-da. Because the fact the other shit triggers, it makes no fucking sense. Unless one of these legs just is broken, just not making a good connection. Oh my god, nothing would make me more angry right now than figuring that out. But we should check it. We should check it. Obviously. So we've been unplugging and plugging this in so many times, maybe we just have a micro tear in our... There we go. Plug you in, plug you in, plug you in. Okay. And so if I go down here and I touch you, I beep here, and if I beep on both of them, which I would imagine I would, yeah, okay, so they're good. Definitely fine. Pull that up. So the only other thing I just did is I just turned the battery off to see if somehow the battery was inducing some weird state. I don't think it can, but anyways, we'll try it. And then I'm going to be done. We'll come back to this tomorrow or whenever I get back to messing with this. The parts to fix that 3DS should be in tomorrow, and we got to do that, so... it's mad because this isn't in. Damn it. No, come back. Come back home. Yeah. Still not doing anything. With the battery off. So if I go across the base and emitter, I should see a voltage, because it's literally just ground and VCC. No, I don't. I'm not. Oh, it might be because it, well, let's make it think that it's good to type. There we go. Okay, it's good to type now. Do we see something across this? What if I hit a button? Okay, I don't see voltage across this. How could that be true? Do I not see voltage on that pin of the... Okay, so turn this off. I would also not see voltage. Yeah, whatever. On like this. I do, I see 18. What about here? I see 17. But emitter just goes to ground. Ground. Where else can I get ground at? Should be an emitter. Anyways. Let's see 5 volts across that. Yeah. Anyways, running out of things to try, so. Oh lord, a 3DS, yeah. Michael says take a hammer to it. Good idea, Michael. I like that idea. How weird is that? How weird. Thinking our 7406 is not doing what it should, but I don't know. It's definitely this back pin that is tied to it. And then where can I get ground? I can get ground like a bunch of places, I would hope. On one of these input caps, I bet I can get ground. Yeah, but not easily. At least not easily from the top. Yeah, that's floating. That's why I'm seeing voltage from that. So where can I get a good ground at? Is this a good ground? This... I can get ground here. Ah, yes, I can get ground there. Okay. So that to that. Yeah, that's ground. Okay, cool. Okay, so now I can test if I turn it on. So if I have ground here, I can test this pin and see if I got voltage. But I got to put my meter to see voltage. That'd be nice. I don't see... Yeah, I see 5 volts there, which means I should see 5 volts here at the base. And I don't. Do I see 5 volts at that resistor that it's running through? I think it's this one. Yes. On the other side of it, I see very little. I see like 500 volt, 500 milliamp or millivolt. So like half a volt. Okay, so the next question is, what is this resistor? Okay, so that's when we ask our friend ChatGPT. I have a orange, white, orange, gold resistor. What is it? And we can also measure it, but measuring these in circuit is sometimes a cluster. So I'm getting 10k ohm, but this is saying that it is 39k. So yeah. Is that the correct resistor, though? Let's see. I'm pretty sure it is. Oh, no, it's this one down here. R32. And that one's 500 ohm. What about... What's that? Red, red, brown. Red, red, brown. Gold. Red, red, brown, gold. It should be 220 ohms. What is voltage drop for 5 volt across 220 ohm resistor? So that should be V equals I over R, right? So we can, voltage drop across will be approximately 3.6. With the resistor working directed directly between 5 volt and ground with nothing else in the way, the voltage drop would be a full 5 volts. The resistor sits on the 5 volt line in the base of the high second 5 volt power wheel, connected to the base pin, joint the transistor contacts 2 internal transistors stacked together. This means it requires about 1.4 of the base to turn on. It effectively locks or clamps that side of the resistor at 1.4. Yeah, even this says there would have to be a brain triggering your transistor to fire. Okay, I agree. I don't really see what brain is doing that. What brain could possibly be doing that? Unless I'm tracing this wrong. I don't see any brains involved in this operation. Does anyone else see brains involved in this operation? Unless these transistors over here are somehow increasing the VCC, and that is what's triggering it, but that doesn't make any sense to me. Yep, VCC, right there. If I do this to this, 500 ohm, yeah, and that's that 500 ohm resistor. Right there. And then the middle pin goes to the actual solenoid, and the far pin goes around here, over here to ground. The only thing I can imagine that would be triggering this would be a voltage fluctuation on the 7406. That's the only way that that makes sense. You have long resin floating around. Oh god. Okay, I gotta go to bed. It's almost 1 a.m. I gotta go to bed. Wait, I might just end up swapping this board, but it would be nice to figure out what the problem is just for fun's sake. But anyways, thanks for sitting around and watching me fuck around with a typewriter. We got a new battery installed, which is cool. We need to fix the other board now too, which I'm assuming is going to be the same voltage regulator that we had to replace in the other one, and hopefully this one works. This one might have the same problem this one does with the hammer, and if it does, then we probably know what other thing we blew up too. But until then, I don't know. So, thanks for hanging out. You agree the chip, the 7406, it's the only logical thing. It's the only thing that could possibly be doing anything. Unless it's not getting a signal to... I don't imagine chips like that get signals to mess with their VCC line, though. That would... Anyways. Until next time, guys. We'll probably do a Game Boy, or we'll do the DS tomorrow if the part comes in time. So hopefully it does, and then we'll clear all this off. We'll do that, and then we'll get back to this later. So, all right, bye.